Hey everybody, this video is going to cover two things. We're going to be looking at recognizing if an equation is or is not balanced, which is the absolute most important part, and then we're going to look at how to make an equation balanced with just a few simple examples. So to begin, we have to look at the law of conservation of mass. And when we deal with this law, this basically says that all equations must be balanced. Okay, so this is what all equations have to be like in nature, because if they're not balanced, then they're breaking the law, which says matter can't be created or destroyed. So when you have an equation that might look something like this, you have a reactant side and a product side. So I'll label that. You have the reactant side, you have the product side. That means everything you have on the reactant side must also be on the product side, but it can be rearranged. So if you have P's, you must also have P's over here. And if you have O's over here, you have to have O's over here. And then the numbers must match up as well. So the first thing we like to do when we try to recognize if an equation is or is not balanced is just make a list of the elements that are in the equation. And I like to do that underneath the arrow, because when I do it underneath the arrow, I can keep all my reactant numbers on the left, all my product numbers on the right. It just helps me keep organized. So in this equation, I see P's, I see phosphorus, I see O's, oxygen, and those are the only elements I see. And then to recognize if it is or isn't balanced, I just count up how many phosphoruses I see right here. So I see 4 P's on the reactant side. And then I'm going to jump across the arrow to the product side. I have 2 P's times the 2 coefficient, because that's our formula rules. 2 times the 2 means there's 4 P's here. So my P's are balanced. That's a good thing. But just to make sure, I need to check my O's as well. Come to this side. This 3 coefficient modifies this O. So 2 O's times the 3 means I have 6 oxygens on the reactant side. On the product side, this 2 modifies this O as well. So I'm going to multiply. So 3 times the 2 O's means I have 6 O's. So this checks out. I've got 4 P's on both sides. I've got 6 O's on both sides. So this is a balanced equation. This is exactly what we need the equations to be and to look like. So let's look at another example. This one right here, start by lining up your elements right underneath. So I've got C's, carbon. I've got H's, hydrogens. Start on the reactant side compared to the product side. So on the reactant side, I see 1 C. On the product side, I see 1 C. On the reactant side, I see 2 times 2 H's, which is 4. And then I also see 1 times 4 H's, which is also 4. So this one also is balanced, which is good. Okay. Now let's check one, and this next one should be unbalanced. Okay, it's a little more complicated. It's got a little longer, but you just take it a piece at a time. Shouldn't be too hard. I've got a reactant side, I've got a product side, and I've got 3 different elements. I've got ALs, and remember, when you see it in print, this is an L, this is an I. Okay, lowercase l, capital I. So this is AL, this is CU, and CL. So these are the 3 elements I see. Okay, on the reactant side, I have 1 AL times the 2 coefficients, so I have 2 ALs. Go to the product side, I only have 1 AL right here. There's no subscript, so it's an understood 1, no coefficient. So right there, I can already see this is unbalanced. I don't even have to go any further. I'm going to finish it just to be complete, but this is definitely unbalanced. On the reactant side for the coppers, I have 1 Cu times the 3, so that's 3 Cus. Over on this side, 1 Cu times the 3, so that's 3 Cus. Then the CLs, just to check, I've got 2 CLs here times the 3 coefficients, so that's 6 CLs. And then I've got 3 CLs here, but no coefficients, so just 3 CLs. So this leaves me unbalanced on these 2, but balanced on this one. But because these are unbalanced, the entire equation is unbalanced. Okay, easy peasy, right? Now, we've been able to recognize balanced and unbalanced. Let's take the next step and try to learn how to balance them. Okay, so this is an unbalanced equation. short version on Y, I've got 4 P's and 1 P, 2 BRs and 3 BRs, so I'm going to try to get those to balance out. So I've got my reactants, I've got my products. I'm going to list them underneath P's, BRs, and just like I said, I got 4 and 1, I've got 2 and 3. Now, to begin, to balance out the P's, I've got 4 here and only 1 here, and when you balance, you can only change coefficients. Coefficients is the only thing you can change. Coefficients would go here, here, or here. Well, I want to make my 4 P's be 4 over here, and when I do any kind of coefficient, I'm doing multiplication. So what would I need to multiply this P by to make it 4? Well, I'd have to multiply it by 4. And that 4 messed up. There we go. So I'm going to put a big 4 in front. That changes my P's. I now have 4 P's, but the 4 also changes my BRs. I have 4 times 3 BRs, which actually gives me 12 BRs. Then I've got to come over to this side. Now my P's are good, but my BRs are off. So I need 12 BRs over here. Well, I don't need to do anything on this B because it's fine. So I'm going to put something right here in front of this BR. I start with 2. So I ask myself, what do I multiply 2 by to make 12? 2 times 6 makes 12. So that's going to give me 12 BRs. This is now balanced. 4 P's, 12 BRs. Announcement. Okay. This right here is another good example, but we've limited it, so it's a kind of a long equation, but I'm limiting it so that we're only looking at one coefficient. So I'm only worried about this coefficient right here. If I can make that coefficient balance, then the entire equation will be balanced. Likely, when it comes to something like an exam, a test, STAR test, this is as complicated as they would get it. Maybe not even this complicated, but this is as hard as you would need to do. List my elements. I see a C, an H, and an O. Inside I see H's and O's as well. So I'm going to count them. Over here I see 1 times 2 C's, so 2 C's. Over here I have 1 times 2 C's, 2 C's. My H's, 4 times 2 H's, so that's 8. Over here, 2 times 4 H's, so that's 8. My O's, there's no coefficient right here right now, so it's just an understood 1, 2, so I've got 2 O's. And then over here on this side, I actually have 2 different O's, here and here, so I have to account for them both. I have 3 times 2 O's, which is 6 O's. I have 1 times the 4 O's, which is 4 O's. So combined on this side, I actually have 10 oxygens. So 10 oxygens. The only thing that's not balanced, my C's are fine, my H's are fine, I have to make my O's balance out. So what do I multiply here to make it 10 O's? 2 times 5, that gives me 10, and now I'm balanced. If you have any questions, come ask us.